Good day everyone, I'm Teacher Justin and let's talk about infinite geometric series. An infinite geometric series is an infinite series whose successive terms have a common ratio. Now, meron tayong dalawang klase ng geometric series. Okay? So, we have a convergent and divergent na infinite geometric series. Yung convergent infinite geometric series natin, meron siyang absolute value ng common ratio that is less than 1. So, pwede nating sabihin na yung common ratio natin dito ay proper fraction. Kapag proper fraction yung ating common ratio, then convergent siya. Now, pag divergent naman, yung absolute value ng ating common ratio is greater than or equal to 1. So, pag sinabi nating absolute value of the common ratio is greater than or equal to 1, yung common ratio natin is either whole number or improper fraction. So, pag whole number siya or improper fraction, then ang infinite geometric series natin ay divergent. Now, balikan natin yung convergent. Pagka-convergent yung ating infinite geometric series, then we will have a formula for the infinite geometric series. Ito yung formula niya. S sub infinity is equal to the first term all over 1 minus the common ratio. Then, pag divergent naman siya, okay, the sum does not exist. So, hindi natin pwedeng makuha yung infinite sum ng ating infinite geometric series. Okay, let's have an example in getting the infinite geometric series of our geometric sequence. Alright, let's have this first example. We have 33, 3, 3 over 11, and so on and so forth. We're asked to find the sum of the given infinite geometric sequence. So, first step natin is to identify the common ratio. So, ang common ratio natin is dividing second term by the first term. So, 3 divided by 33, that will give us 1 over 11. Now, 1 over 11, kunin natin yung absolute value niya. Is it less than 1? So, since it is less than 1, we will have convergent. Therefore, pwede natin gamitin yung formula for infinite geometric sequence. Identify natin yung ating first term. So, ang first term natin is 33. So, let's substitute our first term and common ratio dito sa formula natin. So, we will have S sub infinity is equal to 33 over 1 minus 1 over 11. Now, take note, si 1, pwede natin siyang i-convert to 11 over 11. Kasi 11 divided by 11 is 1. So, kokopyahin lang natin yung ating denominator na 11. Gagawin nating 11 yung numerator natin and 11 yung denominator natin. Para pareho na sila ng denominator at pwede nating i-perform yung subtraction. So, 11 over 11 minus 1 over 11. Let's simplify that. That will give us 33 over 10 over 11. Now, sulat natin siya in this form. 33 divided by 10 over 11 para mas madali siyang computin. Now, let's apply keep, change, flip. So, 33 times 11 over 10. And then, let's apply multiplying fractions. So, 33 times 11, that will be 363, then divided by 10. So, the sum of the infinite geometric sequence will be 363 over 10. And that's it. Tada! Alright. Let's have this second item. We have 12, negative 6, 3, and so on and so forth. And we're asked to find the sum of this infinite geometric sequence. So, para makuha natin yung sum ng geometric sequence natin, our first step is to get the common ratio. So, yung common ratio natin, we will divide the second term by the first term. So, negative 6 divided by 12, that will give us negative 1/2. Then, we get the absolute value of that and compare it to 1. So, we can say that 1/2 is less than 1. Therefore, we can now proceed that this is a convergent. So, pag convergent yung ating infinite geometric series, pwede nating kunin yung sum ng ating infinite geometric series. Using the formula, S sub infinity is equal to the first term over 1 minus R. Okay, so kunin natin yung first term natin. Ang first term natin sa ating geometric sequence is 12. Now, let's substitute our first term and common ratio sa ating formula. So, we will have 12 over 1 minus negative 1 over 2. Now, let's simplify the denominator. So, we will have 12. Then, yung 1 natin, gagawin natin siyang 2 over 2 to represent our fraction form para pareho na yung ating denominator. Tapos, negative times negative will be positive, kaya addition na yung operation natin sa denominator. Then, add natin siya sa 1 half. Now, 1 half plus 2 over 2, that will give us 3 over 2. So, we will have 12 over 3 over 2. Then, let's write it in this form, 12 divided by 3 over 2, para mas madali natin siyang computin. And then, we can apply keep, change, flip since we are dividing fractions. So, keep, change, flip natin. We get the reciprocal of our divisor. Magiging 12 times 2 over 3 siya. Okay? Then, let's multiply 12 and 2 over 3. That will give us 24 over 3. Now, let's simplify 24 over 3. That will give us 8. So, the infinite geometric series natin will be equal to 8. And that's it. That will be our final answer. Tada! Alright. Let's have this third item. So, let's find the sum of this infinite geometric sequence. So, our first step in getting the sum of the infinite geometric sequence is for us to get the common ratio. So, kunin natin yung common ratio natin by dividing the second term by the first term. So, 24 divided by 16, that is equal to 3 over 2. So, let's get the absolute value of our common ratio and compare it to 1. Now, since improper fraction yung common ratio natin, automatic it will be a divergent infinite geometric series. So, since divergent siya, we can say that the sum does not exist. So, since the sum does not exist, then we will have no solution. And that's it. Tada! Alright. Let's find the given infinite geometric sequence of this sequence. So, we have 5 over 2, 5 over 3, 10 over 9, 20 over 27, and so on and so forth. So, to get the infinite geometric series, ang gagawin natin is first, we have to find our common ratio. So, to get the common ratio, we will divide our second term by the first term. So, 5 over 3 divided by 5 over 2. Now, let's apply keep, change, flip. So, 5 over 3 times 2 over 5. Let's multiply them and simplify. That will give us 2/3. Now, compare natin si absolute value of our common ratio to 1. So, we can say that our absolute value of our common ratio is less than 1. So, this is an example of a convergent. So, since convergent siya, pwede natin kunin yung sum of our infinite geometric series using the formula a sub 1 over 1 minus r. Now, kunin natin yung ating first term. Ang first term natin is 5 over 2. Now, let's substitute our common ratio and our first term sa ating formula. So, s sub infinity is equal to 5 over 2 over 1 minus 2/3. Now, convert natin si 1 to 3 over 3 para pareho na sila ng denominator. So, take note that 3 over 3 is still equal to 1. So, kinuha lang natin yung denominator ng ating 2/3 and ginawa natin siyang 3 over 3. So, now let's subtract 3 over 3 by 2/3. So, 5 over 2 all over 1/3. Now, sulat natin siya in this form para mas madali siyang i-divide. So, 5 over 2 divided by 1 over 3. Then, let's apply keep, change, flip. So, keep, change, flip natin. 5 over 2 times 3 over 1. Now, let's multiply 5 and 3, 2 and 1. That will give us the sum of our infinite geometric series, which is equal to 15 over 2. And that's it. Ta-da! Alright. Let's find the sum of this infinite geometric series. So, we have 7 over 25, 1 over 5, 1 over 7, 5 over 49. So, kunin natin yung sum ng ating geometric series by first getting the common ratio. So, para makuha yung common ratio natin, we will divide the second term by the first term. So, 1 over 5 divided by 7 over 25. Now, let's apply keep, change, flip. So, 1 over 5 times 25 over 7. Now, let's multiply. This will give us 5 over 7 pag sinimplify natin. Okay, so 5 over 7 will be our common ratio. And since our common ratio is a proper fraction, we can say that the absolute value of our common ratio is less than 1. And this will give us a convergent infinite geometric series. If our infinite geometric series is convergent, pwede natin gamitin yung formula in getting the sum of our infinite geometric series, which is a sub 1 all over 1 minus r. So now, kunin natin yung ating first term. Ang first term natin is 7 over 25, and substitute natin yung first term natin at yung common ratio natin sa ating formula. So we will have S sub infinity is equal to 7 over 25 all over 1 minus 5 over 7. Now, let's change 1 to a fraction na merong parehong denominator ni 5 over 7. Okay, so let's convert 1. So, magiging 7 over 25 over 7 minus 7 minus 5 over 7. So, pareho na yung ating denominator. So, we can subtract 7 over 7 by 5 over 7. So, let's subtract. This will be 7 over 25 all over 2 over 7. Now, para hindi tayo mahirapan mag-divide, let's write it in this form. So, 7 over 25 divided by 2 over 7. So, let's apply keep, change, flip. So, keep, change, flip natin. Magiging 7 over 25 times 7 over 2. Let's multiply 7 times 7 and 25 times 2. So, 7 times 7 is 49. 25 times 2 is 50. So, our infinite geometric series will be equal to 49 over 50. And that's it. Ta-da! Alright. And that is it. If you like this video, give it a thumbs up. If you have comments, questions, recommendations, suggestions for my next video, please leave them in our comment section below. Share this video and subscribe. And for more videos like this, you can go to my channel, Teacher Justin. And that is it for today. Again, I'm Teacher Justin. Goodbye, God bless, and stay safe. See you on my next video. Peace.